Threadripper. It really is over 9,000 this time. I mean, isn't it always over 9,000? I mean, really, in the scenario, in the context in which it launches, Threadripper is literally always over 9,000. But this time, it really is. Up today, I've got the 9970X and the 9980X, 32 and 64 cores. These are two processors that we're taking a look at today. These are Threadripper, not Threadripper Pro. Let me be clear about that. Threadripper Pro, I know Threadripper Pro launched already. Listen, I'm working on the Threadripper Pro side of things. You're just going to have to give me some more time. It's going to be out later. I don't know what to tell you. The Threadripper platform is TRX 50, as evidenced by the giant pile of TRX 50 motherboards in front of me. Up to 80 PCIe lanes, 5.4 GHz clock speeds this time around, and this is the big one, full JEDEC support for DDR5 6400. The entire memory bump from 5200 to 6400 is huge. The platform really should let Zen 5 shine, should let Zen 5 hit its stride. It's going to be pretty awesome. Let's take a closer look. This is going to be one of the most information-dense reviews we've ever done, I think. This is the same TRX 50 platform that the Threadripper 7000 series launched into. TRX 50, it's not new, but TRX 50 and Threadripper 9000 are going to go together really well in existing motherboards with a BIOS update. And they're available now, basically, the CPUs. You can go run out and buy a 9970X or a 9980X or even the 24-core version. For this video, we'll primarily be looking at our Gigabyte AERO D revision 1.2 motherboard with the 32-core 9970X and the 64-core 9980X. But I've also got the ASRock TRX 50WS and the Asus Sage TRX 50, along with a slightly older revision 1.1 AERO D. 1.1, 1.2, what are the differences on those boards? Two different AERO D motherboards. Yes, two different AERO D motherboards, 1.1 and 1.2. Now for this review, brand new motherboard 1.2, that's what we use for all of our testing. But I also have the older 1.1, and so I thought it'd be fun to play change-o, switch-o, mix up, see what happens. Everything was fine. That's completely fine. Usually with 1.1 to 1.2, there's a change in like the 10 gig Ethernet chipset, like switching from Marvell to Intel or from Intel to Marvell or, something like that. But in this case, I'm not sure, it was memory compatibility or like memory compatibility improvement. The 1.2 board worked great with our V-Color 6400, 7200, and 8000 kit. So that's great. Our G-Skill kit that AMD shipped, it was also 6400, worked great. Our Kingston Fury kits worked great on the 1.2 board. On the 1.1 board, it was a little trouble to get anything working past 7200. Like it would post, but you might get a blue screen or there might be other memory instability, especially with our V-Color 8000 kit. But on the 1.2 board, it was fine. On the 1.1 board, a little sus. This is important to mention because of people that may be upgrading. You may have a 7000 series CPU and you're considering dropping in a 9000 series CPU. That should work. But bear in mind that there may be little compatibility rough edges like that. By the same token, if you were like me and struggling to get, 6000 to work well on your launch day TRX 50, it should work now. It should work with the BIOS updates and everything else. That memory compatibility is conferred. I've also done testing with our 32-core 7000 series Threadripper CPUs, and the memory compatibility has improved tremendously across all of our TRX 50 motherboards, which is great to see, but not really part of this review. Oh, and Linux. If your interest is Linux focused, we've got a lot more technical coverage there, and Linux and the nuts and bolts that go with Linux stuff. There's actually a lot that AMD has opened up with the BIOS and Agiza revisions that are incredibly relevant to the Linux community and Linux compatibility. We've even maybe got a keyhole toward testing CXL memory expansion devices on Threadripper. So we get a little bit more technical over there and break down some differences. And this is stuff that's also going to be available on Threadripper 7000. Some differences between the different TRX 50 motherboards. We'll get into all of that. Check out the Linux channel and the Linux technical stuff if that's your cup of tea. But this is going to focus on performance, including gaming performance and everything else. In the vein of bottom line up front, it's 21 to 25% faster. It's a 21 to 25% improvement over the 7000 series Threadripper, at least for the kinds of creative and rendering workloads that you ought to be running on a platform like this. You can expect, 10 to 15% for other stuff, but 20 to 25% generational uplift, 5.4 gigahertz. You're going to see some improvement that's more than 25%, but mainly in workloads that use AVX 512. So kudos to the AMD team for bringing that out. That's pretty crazy. Broken this review into several sections. One about the CPU, one about memory, one about storage, pricing notes, and a conclusion, gaming benchmarks, that sort of thing. So, use the timestamps, take a look at that. The AVX 512 engine for AI, that's going to be mainly covered in the Linux video, because to get the most out of CPU inferencing, you have to offload a bit of that, and you're going to need, a fork of llama.cpp, and it's off-roading, basically. So check that out. For the graphics side of things, I was able to test with both the RTX 5090 as well as a pair of RTX Pro 6000s here in this system. And I found something really interesting about PCIe and memory bandwidth, and when you start to max everything out. These new CPUs really can feed those 600-watt monster GPUs. So first, let's take a look at our CPU cores. The idea with the move to Zen 5 is that these are the same Zen 5 compute chiplets that exist for AMD's EPYC lineup, as well as their Zen 5 desktop. It's just what else goes with the chiplets. First came Zen 5 EPYC CPUs for server, and then Zen 5 desktop, and now finally Zen 5 Threadripper. The desktop Zen 5 chiplets behind the desktop are behind the desktop I/O die, which is unchanged from Zen 4, and that's basically the same idea here. It's like we just swapped the Zen 4 chiplets for Zen 5, boom, new Threadripper. Theoretically, that means a lot less bring-up time, because you only have to worry about what's going on between the I/O die, which is on the CPU, and the chiplets, which is on the CPU. So there's maybe not a lot for Gigabyte and ASRock and Asus to worry about. If I'm about Ramble for a minute about cooling our CPU, I've got a tower cooler on it now, but I also want to showcase our Silverstone XE360 cooler. This is pretty much the best AIO choice for Threadripper because of its large cold plate design and longevity design for use in server and workstation contexts. We've covered this particular cooler a bunch in the past, but I think it's flown a little bit under the radar. It is undersung. It is amazing, especially if you're thinking about PBO. If you're not thinking about PBO, you can get by with a tower cooler. Now, companies like Gigabyte, ASRock, Asus, theoretically with this setup on this processor with PBO and everything else, like I said, they should have an easier time making their boards work with Zen 5. And it's going to be AMD that's responsible for making Zen 5 actually work. And so when Zen 4 Threadripper launched, we had 5200 memory. 5200 is a weird speed, though. The JEDEC standards go from 4800 to 5600. And 5200 means you actually need 5600 stepped down to 5200. That was weird. Threadripper 9000, full support for JEDEC 6400. And I've overclocked up to DDR5 8000 using a fancy pants V-color kit that I have. There's a little bit of a bleed over here when we're talking about memory and CPU, or memory and CPU sections. But when I was getting the results back, I noticed something odd about our Zen 5 CPUs. The Zen 5 chiplets, topping out at 5.4 gigahertz, in some cases are outperforming our Zen 5 chiplets, the same chiplets, and our 16-core AM5 9950X at 5.7 gigahertz. The answer, the reason, memory bandwidth. Zen 5 launch was a bit rocky. Some people even called it Zen 5%. When, we were looking at that, we didn't call it Zen 5%, but there were mixed results between Windows and Linux. And sure, it was baffling, and sure, Windows was responsible for holding us back in some of those cases, but also memory bandwidth was a bit below what one would expect for Zen 5 on the I/O die. So now with this platform, it's dual channel, right? It's quad channel. We got a quad channel platform. It's easy to test. Is it double AM5 performance, or do we see beyond double the memory bandwidth performance of AM5 desktop? The answer is beyond double. Several different benchmarks show the same sort of thing, but I'll highlight the results from our AIDA64 benchmarks. The 9950X at 6000 is just over 75 gigabytes per second, whereas the 9970X in a dual channel configuration, meaning we're only using 2 DIMMs, also at 6000, is just under 100 gigabytes per second. Step up to 6400 and you'll do even better. You'll get a lot closer to 100 gigabytes per second. And that sort of points to the memory interface on desktop Zen 5 as being part of the Zen 5 launch issues. Don't you think? I mean, maybe, but step up to 4 memory channels here on the TRX 50 platform, and you can easily approach 200 gigabytes per second of memory bandwidth. And that is very, very nice to see on a platform, especially because it goes up to 64 cores, but like 32 cores, it's pretty good. There's some other quirks of DDR5 here. Is it 6400 as an Expo profile, or is it the JEDEC standard for 6400? Expo is always fine, and JEDEC 6400 is not the same as Expo 6400. As you can see here, Expo 6400 is quite a bit faster, but the JEDEC 6400 is more compatible, so it just depends. The Expo profile is going to send more voltage potentially and maybe run hotter. And so enabling Expo, is fine. That's not what I'm saying not to do. Expo is completely fine. That should always be a safe thing to do. But there's a little bit of an overlap here from memory that was designed to run at 6400 and other memory that's overclockable to 6400, which will perhaps demand more voltage and run hotter. And that's something that should be on your radar if you're going to DIY this. DDR5 memory can silently throttle above a certain temperature. What that temperature is and how much throttling you can expect varies from kit to kit. Our G-Skill kit, the 6400 kit that AMD shipped with everything, is great. It's fantastic. You're not going to see any throttling until you hit about 75C. So our G-Skill kit with the Expo 6400 profile, perfectly stable. What about our two V-Color kits? I've got a separate video on a V-Color 7200 kit and a V-Color 8000 kit. And even on Threadripper 7000, the 8000 kit throttles viciously versus the 7200 kit. And the 7200 kit has enormous heat spreaders. They did great. So I can't really recommend the V-Color DDR5 8000 kit until they have similar heat spreaders. At least that's, I think, the easiest low-hanging fruit fix. Or you could do the 7200 if you want to run 7200. Basically, that worked on most of our motherboards with most of our configurations without a lot of headache. At 6400, the Infinity Fabric inside the CPU is going to run at 1920 megahertz, and I didn't find that to be a problem or a bottleneck or anything like that. I mean, theoretically, you can run up to 2000. But what about, what board support? Well, Threadripper 7000 was a little rocky on launch, and I sort of expected it to be problematic, which is why I also tested all these boards for memory compatibility, even our AERO 1.1. However, all of these boards with the latest BIOS have been perfectly stable up to DDR5 6400, even with my 7000 series Threadripper CPUs, which is mind-blowing. The ASRock board has been 100% stable with our DDR5 8000 kit, as long as I keep it below 70 degrees C. Our AERO D motherboard, also 100% stable with 8000, as long as I keep it cool, but it's got to be the Rev 1.2 version of the AERO D, not the 1.1. And, AI workloads are the things that benefit the most from memory bandwidth, and it pretty much translates one-to-one with the overall workload performance there. Fortunately, for this platform, a lot of creative workloads are not really bottlenecked by the memory bandwidth. And so 200 gigabytes per second, which is sort of the upper limit here. I think 256 gigabytes is your fabric limit. That's not unreasonable. And that's for sure something that we'll look at more closely in our Threadripper Pro video, and that'll be out soon, like 4 memory channels versus 8 memory channels. Oh, also, a huge number of people are confused about 4 versus 8 memory channels on the forum. When you look at certain motherboards like the Gigabyte AI Tops motherboard, that's a TRX 50 motherboard that has 8 memory slots, but it does not let you use 8 DIMMs with a non-Pro Threadripper CPU. Just to be clear about that, any TRX motherboard that will support a Pro CPU, but not the other way around. You can't put a regular Threadripper CPU in a Pro motherboard. And even if you put a non-Pro, it's not going to run at 8 memory channels or even 8 DIMMs. Like, it's not 2 DIMMs per channel either. Let's talk about storage of PCIe. Now, I mentioned there was something interesting here. AMD still has RAID mode, and they still have RAID Expert 2. This really isn't changed. I didn't find really anything has changed with their RAID Expert 2 RAID solution in Windows, and I can't really recommend it, except for some really narrow use cases. I mean, it's fine for hard drives and mechanical hard drives array, but as a platform for NVMe, it leaves a lot to be desired. You can check out our other videos or hit me up on the forum if you want to discuss, or if you've been using it for something at scale. I kind of want to hear from you. But I also found something interesting in testing it, though. The peer-to-peer PCIe bandwidth seems much higher on this platform, especially with all Gen 5 devices, than Intel's competing Sapphire Rapids and Sapphire Rapids Refresh platforms. I created a RAID 0 array of 4 of our 4 terabyte T705 crucial drives with our dual Blackwell setup here. In this setup, we have 2 RTX Pro 6000 GPUs, which are Gen 5, and we have 4 Gen 5 SSDs plus the boot volume. The layout here can be a little tough to keep both of those RTX Pro 6000s below 87 degrees C. But in our setup here, there's a gap for cooling between the GPUs. Unfortunately, our Gigabyte AERO D board doesn't expose enough of the PCIe Gen 5 lanes on the platform to do 4 Gen 5 NVMe for our storage volume. You've only got a total of 3 Gen 5 M.2. And the bottom slot, it's 16 lanes, but it's 16 lanes of Gen 4. And there's a fourth M.2 that's also Gen 4. I could do the setup for testing, though, with the Asus the ASRock board with our dual Blackwell Pros, and that is the fastest way to feed data into the 192 gigabytes of Blackwell GPU memory that the GPUs would have. And they communicate directly over the fabric. We can dive into the nuts and bolts of that a little bit more in the Linux video, but it's really interesting looking at the PCIe bandwidth aspect of this. This is one of our Sapphire Rapids refresh comparison systems behind me. This one is the 2595. This is a 52 thread, 26 core. It's like, how does this stack up? How does it work? This is one of the platforms that we're having trouble with the peer-to-peer PCIe latency. See, I've got two Blackwell GPUs in here, and if you run the NVIDIA peer-to-peer latency and bandwidth checker, everything looks pretty good. And the bandwidth from each GPU to the host memory is looking pretty good at about 56 gigabytes per second. And that's true for both GPUs. But these GPUs also support peer-to-peer mode. Well, they'll communicate with each other over the PCIe bus. We're only getting about half speed for some reason, which is roughly equivalent to PCIe Gen 4 by 16 lanes. I'm not sure why that is. The Threadripper platform does not suffer from that. The Threadripper platform is basically twice as fast for whatever reason. But there you go. With that, let's talk about the benchmarks. And the benchmarks, they really are something. Keep in mind that a lot of our testing here is with the Blackwell RTX Pro 6000, but I did also throw in some 5090 testing. I mean, the 9970X plus the 5090 seems like a combination that a lot of people will pick. And yeah, DirectX ray tracing, feature test, 209 FPS. This result makes sense to me. But also keep in mind, Intel's Sapphire Rapids refresh that just came out, at the end of last year, it's a pretty good showing here, especially versus the 7970X, at least at the time. It's like, neck and neck. The Firestrike score here was a little surprising for our 2595X Sapphire Rapids refresh, but the 9970X really is holding its own. It closes the gap significantly over the 7970X. Now, the 64-core parts, it's a lower power budget per core, and so the results here also make sense. And this is a pretty good generational improvement, especially for the 32-core for AMD. For Port Royal, I was a little surprised by the grouping here on this result. This taken by itself doesn't really tell me a lot. Same with Speedway. And Steel Nomad. The Time Spy result here is also really interesting, especially for the Intel platform. One of the key things I was interested in this generation is memory improvements. The memory improvements were so good, we've done several other videos on memory improvement stuff. And the good news is that if you're a 7000 series Threadripper user, you're going to benefit from this as well. There's no reason not to update your platform. Officially, those 7000 series CPUs, again, only 5200 is supported, whereas 6400 is supported on the new Threadripper 9000 series platform. And if you're into AI or any workload that depends on memory bandwidth, this is a serious upgrade. This is one of the most significant upgrades that AMD has ever done generation to generation. Just to give you an idea of how much performance difference this is, here's our 7970X at DDR5 5200. And yeah, it's spread spectrum, so it's like, it's actually 5148. It's not really. It's wobbling a little bit because of the spread spectrum feature. But you can expect about 146 gigabytes per second in this particular benchmark. Now, the 9970X, 180 gigabytes per second with 94 nanoseconds of latency at 6326, 6400 basically. Our 9980X does even better with 192 gigabytes per second. More chiplets, more better. This is a place where I think AMD really should have done a dual GMI connection as on the 9575F. The 32 core, it's like, let's have two connections from each chiplet to the I/O die. I also thought this would be a fun test. So here's our 9980X in a dual channel configuration. Look at that, 98 gigabytes per second at 6200. If you bump to 6400, you can clear 100 gigabytes per second. But this is what I was talking about with the platform and the whole Zen 5 launch. With Zen 5, the I/O die, you look at it and you run the benchmarks and it's like 75, 80 gigabytes per second. They left 20 gigabytes per second on the table with the I/O die in Zen 5 desktop because clearly two channels on our Threadripper platform here, it's only 2 sticks of memory, can deliver 98 gigabytes per second to the platform with the Threadripper I/O die. It's very interesting. Our Sapphire Rapids refresh, DDR5 4800 is the officially supported speed, 110 gigabytes per second, which is still a little surprising given that this is a 4 memory channel platform, and given our other results like Time Spy and things like that. Like, It's interesting. It's A64 too, so take that with a grain of salt. There's no perfect benchmark here because of cache geometry and everything else. The Intel memory latency checker on Linux is another good one, which is in our Linux video if you're worried about A64 in particular, but it's fine. I sort of treat Blender as an artificial benchmark these days, and so if we take a look at our classroom result, yeah, the 9980X is gonna take the lead there. PBO, with and without PBO, 479 to 502, PBO can make a big difference. It's also important to point out I had zero stability issues with PBO. When I turned PBO on and let it do its thing with the Silverstone AIO cooler, it kept the CPU cool and I had zero stability issues. Very surprising. It's a very good result. So I think it's like, oh, overclocking. I don't know. If you make money with your computer, I hesitate to recommend that. But that's a pretty good upgrade. It's also a pretty significant generational upgrade from the 7000 series to the 9000 series, core for core. And in the Blender classroom, 16%, give or take, a lot more if you throw PBO in there. Generation on generation improvement. Similar breakdown for Junk Shop and Monster. You definitely get a higher PBO benefit from the 32 core than the 64 core, but I noticed that this is probably to do with power delivery, using Hardware Info 64 on Windows and just looking at the power delivery to the socket, like 450 watts. So you're giving your CPU another 100 watts or so, and I think that's probably also why I didn't experience any instability. We're not pushing it to the ragged edge. We are just letting those cores consume as much power as they want, within reason. Is a 450 watt desktop CPU within reason? I think it is. As a great Gordon Mung used to say, it's like, I don't think people really care how much power their desktop uses as long as they can plug it in and use it without tripping a breaker. I've also got the GPU focused results for Blender here, and this is not really part of the CPU test, but I did find that when you've got these monster GPUs, having a lot more CPU horsepower can make a little bit of a difference in terms of how well fed the job is to the GPU. Like the CPU is, being used to feed the GPU. Blender obviously is not a workload that is very demanding of the CPU, but nevertheless, it does make an interesting measurable difference. Cinebench, that's a perennial favorite, right? Look at that 9980X with PBO. And again, this is not an ice bath. This is nothing special. This is the Fractal Meshify 3 desktop, like a desktop machine. It's not even an open air bench. It's just a normal configuration. And look at that. Look at that score. It's just beautiful. Even without PBO, you're going to get 115,000. Again, significant generational uplift. Single core. This is also a single core illustration. With PBO, your single core performance, your lightly threaded workloads aren't going to change much. AMD is already squeezing as much as they can out of those cores in single thread. You can adjust the boost curve, and you can go into Curve Optimizer, and you can go into Curve Optimizer on a per core basis and spend the time to find which cores perform a little bit better and squeeze better performance out of this. This is fully auto though. And again, no stability issues, just letting it automatically do its thing. Your mileage may vary on that, however. And that same kind of thing is true with Cinebench 24. There's really not a lot of difference with PBO on or off for single core. Our 9970X does pull slightly ahead in single core workloads. I always like to do CPU-Z testing just to, get a baseline, see how we're doing. Interestingly here, the 9980X does slightly better single thread with PBO versus our 32 core counterpart. Everything lines up here about how I would expect. And the same is true for the multi-thread. 57,000 in CPU-Z, my goodness. I also like to test with Geekbench just to see how Geekbench breaks down. And Geekbench is showing that our single core score here is a fair bit faster than our 9980X. Geekbench 6, our multi-core score, our 9970 is pulling ahead of our 7980, the last gen 64 core. And this is because even the multi-core Geekbench benchmarks are not really all that multi-core. We're doing some photogrammetry tests with Metashape, Agisoft Metashape, and I was surprised the gen-on-gen uplift from the 7970X to the 9970X. Now this is software that works great on a 9950X, a 16-core, and is really not super well optimized for multi-core or even multi-GPU. But with our RTX Pro 6000 and its 96 gigabytes of VRAM, it was posting some really impressive results for things that would actually use the GPU. Significant uplifts when you need the VRAM. Of course, if you have a job that doesn't need that much VRAM, then you'd be better off getting a less expensive GPU with less VRAM. But I was curious about what sort of a difference the CPU could make. And in, some of the jobs, like the depth map, it really doesn't make a significant difference, but moving from 7 minutes and 10 seconds to 6 minutes and 26 seconds in the, SFM match step, that could be a big difference, especially if you have larger workloads. Texture blend from 2 minutes and 15 seconds to 1 minute 44, you're saving 30 seconds there. That's a significant percentage. In the move from Zen 4 to Zen 5, there are some significant differences, and it is very nice to see no regressions. Of course, the Zen 5 AVX 512 is twice as fast as Zen 4, so that'll help with pretty much any job that depends on AVX 512. Love PugetBench for testing creative workloads, and of course the 9980X is dominating pretty much everything, followed by the 9970X. Now PugetBench doesn't really stress the VRAM, so a 5090 with its slightly better clock speed situation, it pulls a little ahead of the RTX Pro 6000 when we're talking about our 9970X. There really isn't a significant difference here for the scale of tests in PugetBench between the 32 and the 64 core. I think it is interesting that the 9980X with a 5090 does do a little worse than the 9980X with the RTX Pro 6000. And again, this is down to that 64-core CPU can keep the RTX Pro 6000 fed a little better, but this is not enough of a difference in the benchmark results to justify the cost difference. IMHO. In terms of generational uplift from 7980X to 9980X, this is significant. However, Windows is still terrible at dealing with more than 64 threads in a processor group. This is nothing new, and if these words are new, you've got a little bit more research to do. Windows historically, and up through 2025, handles processors that have more than 64 threads in a processor group quite badly, and that continues to still be the case. AMD gives you some options in BIOS to make your 64-core processor appear like it's two processors, and they also have ways of mitigating this in their chipset driver and everything else. And so that has improved significantly from the 7000 series to the 9000 series generation, and updating your platform and your drivers will help if you are on 7000 series. And so if you look at this, it looks like the 64-core part from last generation is doing not great. It's not actually as bad as the graphs make it look. It's just because this is how it was until you get the software and platform updates and that sort of thing. You can claw back a little bit of performance. You can also claw back a little performance disabling SMT if you find yourself with a workload where Windows is struggling to manage the 128 threads, because if you disable SMT, you have 64 cores and 64 threads, and Windows can actually handle that situation a little better in some of those like legacy software applications than if you have 128 threads. Now, if your software has been updated to deal with Windows chicanery around the 64 thread limitation in a processor group, then the application will perform really well on its own. But After Effects, it depends on the plugin. Like, there's a lot of After Effects plugins that just don't take this into account. It's a mess. It's a huge mess. Photoshop, of course, 32 core is the way to go. No brainer, makes sense. Similar stacking with Premiere Pro as well. It really, if you need more than 32 cores with Premiere Pro, you're doing some really insane stuff on the timeline. But for PugetBench, it's a pretty good grouping, and the grouping is about how you would expect. Let's do games. You're gaming on an $8,500 GPU. Well, you gotta fill the hours somehow. How is Assassin's Creed Shadows moving this much faster on a 64-core CPU than the 32-core CPU? That seems odd. And yet, here we are. This is 4K. Let's step down to 1440p. Okay, this is looking a little bit more reasonable at 1440p. This is really good grouping. There's really not a meaningful performance difference from the 9970X to the 9980X. Intel and last generation also holding up pretty good here. At 1080p, where you should be CPU limited as opposed to GPU limited, there are still some differences here. The 7980X is doing well. It's sort of surprising. There are some 5090 results in here, the 9980X with the 5090, as well as the 9970X with the 5090, just to see what they would do, and the performance is pretty similar. Although, I was a little surprised by the 1% lows. I also wanted to check Baldur's Gate 3 in both DirectX 11 and Vulkan mode. 4K posts an impressive result, as does 1440p. And at 1080p, we still have some clear delineation between last generation processors and current generation processors. 1080p is actually where I would expect to see the most difference, because the platform is a much different geometry than desktop. Desktop is where 1080p can shine in a lot of ways, because desktop is going to have the clock speed advantage, theoretically. With Vulkan and Baldur's Gate 3, it's a pretty similar breakdown. These 9000 series CPUs really do a good job keeping the game engine fed. Even a now ancient game like Borderlands 3 does show a little bit more difference than I would expect, and this is a really interesting result in that the 7000 series CPUs are pulling ahead of their 9000 series counterparts. If we step down to 1440p, the gap starts to narrow, and the 9970X moves up the rankings a fair bit. And at 1080p, there's not really a meaningful difference here between the top 5 things. Again, given our artificial benchmark results, the Intel results here are a little surprising. Clair Obsur Expedition 33 is a ridiculous amount of fun. The Epic preset is a ridiculous amount of fun to play in this game, and the experience here was pretty enjoyable basically across the board. Of course, our 9000 series CPUs are leading the pack, but the 7000 series CPUs are also doing really, really well. I mean, basically, every CPU is doing well here. If we step down to 1440p, we start to get a little bit more separation between our CPUs, but there isn't really anything unexpected here. And at 1080p, we maybe get a little bit more separation, but again, a lot of enjoyment here. Notice that the performance increase was not significant, not really as significant as you might expect, moving from 1080p to 4K. I mean, 1080p is only a quarter the pixels, so we should be getting 4 times the frame rate, right? Like, no, something in the engine or something in the Epic preset, difficult to deal with, so it gets a little faster, but not dramatically so, especially not the 1% lows. Cyberpunk 2077 with the ray tracing, this is the 4K ray tracing ultra preset. Yeah, those 9000 series CPUs just going to town. And this is one game where the 5090 does pull a little ahead of the RTX Pro. And the 9970X is a little better than the 9980X for gaming. I mean, conventional wisdom is that the 32-core higher power envelope, more power per core, you can get those higher boost clocks more toward that 5.4 gigahertz boost ceiling than you would expect with the 9980. And so that fits with the expectation, although I don't know that we've seen that in any other games, especially like, Assassin's Creed. That was an interesting result, I thought. Final Fantasy Dawntrail 4K high preset. Don't know what's going on with that game. The 1% lows are worrying here, but it's a cross-platform opportunity for whatever's going on. This is really good, a really good result for the 9000 series CPUs. The theme here that I'm starting to take away with the 9000 series CPUs is that 4K, 1440p, as we see on Dawntrail here, and also stepping down to 1080p. The gaming performance difference between desktop Zen 5 and Threadripper Zen 5 is narrowed significantly versus desktop Zen 4 and Threadripper Zen 4. It's probably a big deal for game developers because you can be running lots of background jobs and doing stuff with your game, developing your game while also running your game and getting an idea for what somebody that has the same core on desktop is going to experience without all the cruft of the development experience running in the background. Monster Hunter Wilds at the 4K Ultra preset, stellar performance. Same with 1440p and same with 1080p. And also notice the performance here with Monster Hunter Wilds really doesn't scale. Like it's really, the CPU is doing everything that it can. It's more to do with the game engine. Maybe we'll see a difference with the Ultra preset and ray tracing. Still 106 FPS and 101 FPS on our 9000 series CPUs. It's not significantly faster than the 7000 series CPUs, but it is measurably faster. The 1% lows are more better than the top line average FPS, in my opinion. And that's something that holds true as we step down to 1440p and even 1080p. And again, surprising here that there's really not a huge difference in overall performance. What about an ancient game like Shadow of the Tomb Raider, 4K, highest preset, 272, 266 FPS across the board? What if we step down to 1440p? It's not significantly faster. It's not significantly more FPS. 1080p, it's not significantly more FPS. What a time to be alive when the gaming performance between 4K and 1080p is not meaningfully different because the machine that you're running it on is so completely bonkers insane. What about Silent Hill and the 4K Ultra preset? That's 83, 84 FPS basically across the board. Everything's above 80 FPS. This game, interestingly, the 9980X with the 5090 falls behind our Intel Sapphire Rapids refresh by just a hair, and it's more to do with the 1% lows than the average FPS. The 7980X also suffers similarly. So this is a game that's, I don't know that I would really read too much into that because there's still less than 10 FPS variance in our top line numbers. At 1440p, we get a little bit more separation. The 9980X here comes out on top, followed by the 7970 and then the 9970. And there was a fair bit of difference between the 9970. I think it's interesting that the 1% lows improved very slightly, but the top line average FPS comes down slightly. In playing this game, I was trying to feel a difference, and it was subjectively, I couldn't tell. I actually thought something must be broken, changing the resolution. And it's like, there's nothing happening. And it's like, well, between 4K and 1440p, but presets. Same story at 1080p. All right, Callisto Protocol, 4K Ultra preset, over 200 FPS with 100 FPS on the 1% lows. By the way, playing a game that has this kind of swing on an OLED monitor that is doing, you know, like the FreeSync, G-Sync thing, it is, you can tell something weird is going on an OLED display, but it's not nearly as off-putting as what I've experienced with like 4X frame gen on lower tier cards. So like a 5070 Ti with like the 4X frame gen is a lot more off-putting than the experience here in the Callisto Protocol. I don't know that, I mean, is anybody still playing the Callisto Protocol? It looks pretty, but it was just something subjectively that I was going to call out there. The 1440p Ultra preset, it was much less noticeable than 4K for whatever reason. And then, of course, the 1080p. The other surprising thing here is that our 1% lows, even at 1080p, not significantly improved. It suggests engine or something like that type of, like, it just didn't figure that anybody would ever have a computer that could actually have an average frame rate of 200 FPS. I know a lot of our audience has been playing Oblivion Remastered, so at the 4K Ultra preset, yes, it's a pretty playable experience. At 70, 72 FPS, 69 FPS, pretty much all of these systems will do really well. And the Xeon, for the first time, this is the game where the Sapphire Rapids refresh really moved up the stack. It's not significantly faster or slower than any other machine in the stack here, but it's doing pretty good. I was also a little surprised to see that the 9980X plus the 5090, sort of being at the bottom of the stack. But it's a difference between 63 to 72 FPS. So, I mean, it's really not that significant of a difference. It's pretty much the same story, stepping down to 1440p and even 1080. Although at 1080, we did get a little bit of a performance bump in our average FPS, but I would just play this at 4K if you had this kind of machine. Ultra with ray tracing also didn't make a huge difference in frame rate. It did bring us a little below 60 on most of these configurations, but overall it was a very playable experience. 1440p definitely felt a lot better. And at 1080p is really the only place that I would say that you start to feel a meaningful difference between machines and configuration, but it is minor at best. So there you go, there's the gaming benchmarks. What's my takeaway from the gaming benchmark? This is a machine that you should not buy for gaming. You can do game development on it. You can have a game or 5 running in the background with no ill effects. If you get the 64-core processor, you could create a Windows virtual machine in Linux and pass through a multi-instance GPU slice of a Blackwell Pro RTX 6000. That's right. NVIDIA officially supports taking your 96 gig GPU and cutting it in half or cutting it in quarters, and you get an SR-IOV GPU. The problem is if you have VBIOS 2.52, it's bugged and it doesn't work, and there's not a fix or an update or a downloader for that. You can RMA your card because there are cards in the wild that have a newer VBIOS, but NVIDIA is hesitating to release a VBIOS update to enable multi-instance GPU. We'll talk more about that in the Linux video, but you could do that now. Have like slice one GPU into 4 pieces and have 4 24 gig GPUs running different stuff, and you see what kind of a monster it is. And so that could enable some really amazing multi-platform game development workflows. But I'm getting off topic. This is just the monstrous game performance, where the game performance here is so insane that the results really aren't super meaningful, other than AMD has closed the gap for gaming from 7000 series to 9000 series. There really is not, in my opinion, a meaningful performance difference for game performance between desktop and enterprise class CPUs now. And that's amazing. So good job, AMD. There's one angry guy in the back that's yelling that, well, of course it's that way because the I/O die on desktop Zen 5 is so terrible. Or now we have the proof that the desktop I/O die is terrible. And that's like, it's not terrible. It's fine. It's a desktop class I/O die. They do leave some Zen 5 performance on the table. And that's also why Linux was probably a lot better, is because the kernel was doing a lot better. The Linux kernel was doing a lot better juggling the resources that it had But I digress. So we have 3 CPUs in total launching in the lineup today, 24 cores, 32 cores, and 64 cores. And you can use the Pro CPUs on TRX 50 motherboards, but that really only makes sense maybe for the 16-core Pro CPU that launched already on the 23rd. One key thing about pricing is the desktop Zen 5 users have the best price per core going. $700 for 16 cores. One might hope for 32 cores for $1,400, right? No. No, in a lot of ways, it looks like TRX 50 has more or less become the sort of an on-ramp for AMD to bring people to the Threadripper Pro platform and maybe even Epic platforms. I mean, look at AM5. A lot of software has trouble making full use of all 16 Zen 5 cores on the 9950X. I think the places where enthusiasts bump against the limits of the 9950X are more to do with PCIe lanes and memory bandwidth. That's really where I see the limitations on our user forum and from other users like you. So I think it's a bit of a stretch to call this platform enthusiast anymore. The enthusiasts are pinching pennies and hoping for a good deal on used CPUs on eBay. I mean, would you buy a $999 24-core Threadripper 7000 series CPU from eBay? I mean, this is a solid platform for video editing and CAD and photogrammetry and more, but you're going to get work done with your machine. It's not just an enthusiast machine. I mean, the photogrammetry benchmarks alone were especially interesting. The AM5 9950X makes a great photogrammetry solution with Metashape, and they've clearly got work to do in optimizing their software for modern core counts and modern platforms to take better advantage of it. But it did scale decently well for Threadripper when working on larger jobs, or when having more faster GPUs that, the software needs to keep those GPUs fed. Threadripper Pro is not going to hurt you in that scenario. And if you look at the total cost of the system and the total cost deltas, it's like, how much more expensive is it if we just go Pro? Well, it's not really that much more expensive. But a non-Pro Threadripper can be the biggest bang for the buck in those scenarios. So if you know what you're doing, you can save a few bucks and not go with the Pro platform. And Intel, we saw in the benchmarks, and we saw the Sapphire Rapids side by side. Sapphire Rapids and Sapphire Rapids refresh is just not competitive. Xeon 6 for workstation should be out soon, though, and that's going to be a performance leap from Intel. Intel could offer some options around the $1,000 price point for enthusiasts, and that might make sense to them. Maybe that might prompt a response from AMD, but chances are Intel's pricing is going to be comparable because this is reasonable for workstation pricing. Bottom line, this is a huge step up from desktop, and if you're looking for doing something that needs 24 or 32 cores, this platform is a no-brainer. I think that up to 256 gigs on TRX 50 is practical. 64 cores is also doable here, but, and the memory, you can go up to a terabyte. But if you're thinking of a system that's 64 cores and a terabyte of memory, you'd be hard-pressed not to consider Threadripper Pro over Threadripper. I mean, if you're spending that kind of money and you aren't really sure if you should go with Threadripper or Threadripper Pro, then spending extra for Threadripper Pro is really not a huge difference. Consider that 512 gigs of memory and 4 64 gig sticks is going to set you back about $5,000. So, you're not really spending that much more to just go to Pro. It's been 7 years of Threadripper, and you got to hand it to AMD. It's become an irreplaceable component in many people's workflows. If you're on a 5000 series Threadripper or older, now's the time really to start working on upgrades. I mean, for the types of workloads that ran best on the 3000 series or 5000 series Threadrippers, this platform is like creative stuff, rendering, that kind of thing. You're going to see probably a doubling of performance over that generation of Threadripper. AMD has come a long way in the intervening generations. This platform really is over 9000. I'm Wendell, this is Level 1. This has been a quick look at the 9980X and the 9970X from AMD. AMD, they've done it again. Congratulations are in order. But also, good lord, the performance. Is there something that slots in between the 9950X and the 24-core Threadripper? Where's it at? Let's discuss in the forums. I'm signing out, and I'll see you there.